Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocket Man, and we are talking about science, space, and economy. Hey, Ben, how are you doing?
Hi Simon, how's it going? Hi Econauts. So Simon, what's the topic today?
Our topic today is space debris, and maybe you can let us know what is actually space debris.
I think for this talk, let's limit the space debris definition a little bit to anything near Earth. Otherwise, technically speaking, anything, even when asteroids collide and then there's uncontrollable particles of the collision floating around, could be defined as space debris. But for this talk, we limit the definition to anything human-made in near Earth distance. So anything, let's say, between Earth surface and geostationary distance.
So, what exactly is then space debris? What would be classified as space debris by this definition?
So any there also has the name space junk a little bit,
Yeah.
and that is, I guess, giving a little bit more um, a hint what we mean by that. So it's anything which we don't want in that realm in the orbit around Earth. So anything which is generated when we, for example, send a satellite and then there's a malfunction, and from chipping off a little bit of paint up to losing a whole part, or breaking off something, flaking off something, losing a wire, a screw, a collision between things. We had a test, I think it was last year. There was a weather satellite shot off as a test from, I think it was done by China. So there was also a huge cloud of space debris generated. There's many things, and just to give you an idea, so it might sound very harmless, a bit of paint chipping of a surface, but if you have a particle, even if it's just a millimeter small, traveling with nearly 5,000 kilometer per hour in orbit, and it hits something,
It's not
it
a
it,
good it's
it
not a
is
good day when that
no, no.
happened.
No, it's not. Definitely not.
It's not a good day
In the
when it's
best
there.
case, it just penetrates and does nothing. The worst case scenario, the kinetic energy is completely transformed into the surface, and you can destroy quite a few things with this.
And
But usually it would penetrate.
I think it's also important to mention so that the viewer has a little bit a better idea. I mean, yes, paint is one thing, but also space debris that it's like produced by us. If we are talking about space junk, it's obviously we have to think about all the rockets that we have already sent, because depending on how many stages a rocket has, they have to eject them at some point, right?
Yeah,
To
so
make room for
some
the
some
next
parts of
stage.
it, most things would fall back to Earth and then splash down in the ocean. And also, most of the space debris will, over time, deorbit. So there's not enough kinetic energy, so there's no propulsion system on space debris. Otherwise, we could control it, and therefore, eventually, it will fall down. But for some space debris, that could keep that it could stay there for centuries. So it's for our purpose, too long.
That's exactly what I
Yeah.
was referring to. So if we have now defined pretty much what space debris is, so how much debris are we actually talking about?
So currently, I think the number is around 27,000 individual items. And that, as I said, that reaches from small millimeter parts up to larger parts. We have a graveyard orbit, which is outside of the geostationary orbits, usually used for old geostationary satellites. They, at the end of their life, get sent there. So they have like a last boost, and then they get sent to the graveyard orbit. It's a designated station, more or designated orbit for them, but it's also technically space debris. And therefore, we want to manage it. And in the moment, the only thing we can really do is giving us at least situational awareness of how much and where the debris is. So it's constantly tracked, so that if we have other things such as satellites or the space station, they know more or less. Ideally, they know if they are on a collision course, and then they can readjust their path.
That is leading to my next question. So why do we have to care?
Space debris, as I said, has a very high kinetic energy because of the velocity it's traveling with. And if you have operatable things such as a space station or other satellites, and they collide with space debris, they can severely be damaged by it, to a degree that they cannot function anymore at all. And in the worst case scenario, the worst case scenario is that a cloud of space debris starts to collide with, for example, Starlink, a whole constellation of satellites, and then this could react in a chain reaction, which then sort of generates more and more space debris, and eventually devours all functioning satellites we have in orbit.
So what kind of options do we have? I think, and I'm just, thinking about a couple scenarios. I think one option, it's pretty much obvious to send the debris into an orbit where they basically burn up, or maybe land in the ocean so that we can collect them. But is there any other option that we can
Well, I mean,
clean up the space debris?
there's lots of research going on in this area. So there's many ideas from small robots collecting them piece by piece, to nets or a gooey mass to capture them. But so far nobody really has solved the problem. So it's an existing problem in orbit, and we have so far not found a solution for it. One way to mitigate it is that, I guess since a couple of years, if I remember correctly, everything which is sent to orbit has to have a certain management plan to deorbit after 5 years. So you have to already plan into your mission that exactly what you mentioned before happens within a certain foreseeable time frame. So that Starlink satellites, for example, they will low Earth orbit is a little bit easier in that sense as well, because we still have a little bit of atmosphere and therefore friction and therefore deceleration processes in acting on anything there. But anything which is sent there has to deorbit. That means has to fall down to Earth after 5 years. But that was not always the case, and that is the reason why we have many things which are not deorbiting in that time frame. And also, if you think of even if there's a malfunction, a geostationary satellite might still have a little bit of fuel left to be sent to graveyard orbit, for example. But if you have a malfunction, then you can't do that. So many things were not foreseeable at that time, and yeah, we don't really have a solution for it.
So I think an ideal option in the far future would probably be, because we talked about space mining a little bit in a different show. If we have a space station equipped with little robots that would collect them and maybe recycle them,
Yeah,
that would be an ideal situation, because that would also help us with future problems, because we are obviously if we have to replace satellites, then that means that we have like new space debris that
exactly. Yeah.
it is much easier to collect it and recycle it instead of sending it back to Earth all the time, I would assume.
Yeah, and there's a huge opportunity really, like alone in this realm. So most satellites, they are not, it's not very modular. It's not like every satellite is built with the same frame and with the same modular pieces and interfaces. So not every, but most satellites are very individual in their design. If you would start to standardize things like, every every satellite has to have a refuel port. Every satellite has to have a docking port. And so on. If you have many of these things, you automatically reduce in the future the amount of space debris as well, because not only can you potentially reuse things in space, also end of life could mean a later time. So one reason often satellites are limited in their operation is the amount of fuel you can carry with them. If you could refuel them, you can use them longer, and they can also avoid collisions longer, and therefore reduce less space debris. So there's many opportunities, and my personal view is that the major step we have to do is we have to establish a reliable and dynamic infrastructure to get to orbit in the first place. That doesn't mean that we have to clog up more, but if we make it more affordable and democratize access to orbit, that would also mean that we give the opportunity to more people to solve that problem.
Yeah, you made a very good point when you said like we need certain standards. If we look at computer, for example, that's exactly what happened too. Everybody, I remember in the 80s and 90s, everybody has their own system, which means that you had to get the certain devices for that system. Today, everything is compatible with. It doesn't matter if you have a Linux, Windows, or Macintosh. Um, Certain things will work on either device. Even
Yeah,
if you think about like communicating with your mobile devices, iPads and what have you, right? There are certain standards in the industry now that makes it so much easier also to develop new things. And I think that this is a very good starting point also for sending something in orbit, making sure that there's a certain standard to make sure that there's less debris, or if then at least we know what it is and can then maybe have like action in place, like recycling, for example, right?
yeah. Also, I think this is also another good addition to Starlink, to mention that again, because Starlink will have so many similar satellites in orbit, up to 44,000 if they go ahead with their big plan. That means you have 44,000 almost identical. I mean, there will be iterations, obviously, but they will have a similar design. That means there's an opportunity to, you know, reuse parts if they are designed this way. So if you have that many,
Absolutely.
um, the problem nowadays, if you have a satellite, in order to get to the inner parts of the satellite, you pretty much have to break outer parts to get inside. There's no USB connection port where you can quickly upload new software. Um, and also, I mean, at some point, even that makes no sense anymore. Some of the satellites which we are still using, they're using technology from the 80s. And maybe at some point you want to replace that. That's not possible if you have not built it in a modular way.
I think
So
I think a very good, in my opinion, at least, a good starting point would be uh, having a space shuttle that is capable of collecting the satellites in space.
funny you say that. The space shuttle could collect satellites
Yeah, that's
in
exactly
space.
that's exactly why I was mentioning that, because that's exactly the reasoning
And
why.
it was designed to collect
Yes,
satellites, not to deliver satellites. But that's a different story. That's a very different story. Well, I mean, the space shuttle was a very cool idea, let's say. But I think SpaceX is doing it much better, and they can reuse their rockets as well. So you have pretty much you have your satellite there. You just have to set up a module which would be sent up with the rocket to collect things, and which could then land again. So you need to design a lander, or as you mentioned before, even better would be if we can recycle the parts, because sending the material up there was expensive enough. Why
exactly.
bring it back? It's already there, and
Yeah,
maybe we can use it again. But as you know, recycling is not that straightforward.
exactly. Yeah,
It requires a
especially if
lot
you have
of
so many
energy.
different parts inside
Yeah,
technology. You have like so many different resources that needs to
yeah,
be melted down in different ways. So yeah, and I absolutely can imagine having a space station that it's like designated to do exactly that, right? But especially when we have more stuff in orbit, sending it doesn't have to be a shuttle, but something like that. Uh,
I look,
you know,
I understand. Yeah.
having like
Well,
like
I mean,
something that is
one
collecting
thing
them.
is, yeah, one thing is certain. We need to tackle the problem. So there's definitely an issue here. Space debris is an issue. It will be even worse in the future if we don't tackle it, and therefore we need to find ways to mitigate space debris.
Yeah. All right. Well, thank you so much for your time. That's already it for today. I hope you had fun a little bit listening to us rambling about space debris. Um, if you like, leave a like, and don't forget to subscribe if you haven't already. We also like to hear from you, so if you don't mind, leave a comment and don't forget to share the video to help us getting more subscribers. All right, thank you so much for your time, Ben the Rocket Man, and I will see you
Simon,
next time. Bye bye.
bye.